Okay guys, this is video lesson 10-4 part 2. This is where we're going to just go ahead and do 4 examples of what you learned in part 1, which was how to graph a quadratic function. First of all, I want you to see here that I have answer blanks kind of set up for all 4, or for both graphs here, actually all 4 graphs. Notice that the numbering is a little bit, I'm going to change the numbering right now a little bit. You have answer blank 1, 2, 3. 4 is really this T-chart down here, so change the T-chart into number 4, and then we'll have number 5 being this answer blank up here at the top. This then will match what we had in part 1 of this lesson, and the fact that there are 5 kind of steps that you need to go through to graph a parabola. Alright, so let's just get right to it. Here's my problem. In number 1, here is my quadratic function, x squared plus 7x plus 12. Again, you might want to jot down that in this first problem, a is 1, b is 7, and c is 12, because you may need to use the quadratic formula, and you definitely have to use, for answer blank 1 here, the axis of symmetry. Finding the axis of symmetry, and we learned that that equation is x equals negative b over 2a. So for number 1, actually I'm going to move this up a little higher, give myself a little bit more room to work. So axis of symmetry is x equals negative b over 2a. So for problem number 1, I'm going to have x equals negative b would be negative 7 over 2 times 1. So I have x equals negative 7 halves. Now, I might want to go ahead and in this problem change that to negative 3.5, because again I have to draw a vertical dotted line on my graph. So I'm gonna go ahead and set up a XY axis here. I'm gonna go kind of right in the middle. Now, this is kind of dangerous setting up your XY axis this early, because you might have to adjust it later. I've already done this problem, so I know this XY axis here is going to be just perfectly fine. And I can then start to draw my dotted vertical line where x, and again this is my x-axis, this is my y-axis. I can draw my dotted vertical line where x is negative 3. Well, here's negative 1, here's negative 2, here's negative 3, so right here is negative 3.5. Now, you don't want to leave those dots there. I was just showing that as I was counting. But here's negative 3.5, and so I am going to draw my vertical dotted line right down this alleyway here. Alright, and again, that's not really part of my parabola, it's just going to kind of show me the center of my parabola. So I'm going to, in blue, kind of check mark off what I've done over here. I've found the axis of symmetry. Sometimes I make people write a period s representing that's my axis of symmetry, x equals negative 3.5. Next step is capital V standing for vertex. You need to figure out your vertex. So down here at the bottom of the page, I'm going to call this my workspace. To find your vertex, you take this negative 3.5 that you found for your x, and you plug it into your x. And you, again, remember that 0 is kind of the same as your y, so you know your x is 3.5, negative 3.5, and you're trying to find y. Again, this is like y equals this quadratic equation here. Actually, you know what? I'm going to write that right above here. So it's the same thing there. So you have, and again I'm going to erase this. So you have x is negative 3.5, so I'm going to go down to the bottom of the page and I'm going to write negative 3.5 squared plus 7 times negative 3.5 plus 12. And again, this is y equals. I'm trying to find the y of my vertex x comma y ordered pair. So you're going to need your calculator. Do a little calculating here. Negative 3.5 squared is positive 12 1/4. Negative 7 times negative 3.5 is negative 24.5. And then we have plus 12. Now you can do all that on your calculator also to find out your y. Y equals, I'm going to do 12 1/4 minus 24.5 plus 12, and that gives me negative 1/4. Now, that makes for an interesting vertex. Come up here in my vertex spot, I'm going to write an ordered pair, and the ordered pair of my vertex is negative 3.5 comma negative 1/4. And I'm going to graph that. So I'm going to use black now for my, actually you know what, I'm going to use blue for my parabola. Negative 3 comma negative 1/4 would be right there, just below the 0. So in other words, this dash right here would represent the negative 1/4 on the y-axis. And so there you have it. There's your vertex. Step 3 is determining whether that vertex is a max or min. And again, that is all based on your a value. So up here, my a value is a positive 1. Positive 1 tells me that the parabola is going to open up. Again, I don't know how wide or how narrow. I just know that it's going to open up, making that ordered pair the lowest point or the minimum point. It's the lowest point of the parabola. Keep this consistent, make that black. So as far as max or min goes, that is the minimum point. Next thing I'm going to do is I'm going to fill in my XY chart. Now, here again, this is kind of some helpful hints here. Right in the middle, I'm going to write negative 3.5, and that produced a negative 1/4. Because after that, again, that was my vertex. I don't have to use fractions anymore. I don't have to use mixed numbers and fractions. I can use nice whole numbers. So again, I'm going to go back to my graph and I'm going to say, okay, what is just right to the right and right to the left of my axis of symmetry? In other words, if this red line is on negative 3.5, what's just to the right and just to the left of negative 3.5? Well, a half a space to the right would be right here, and that point, or that x, would be negative 3, right? So you have negative 3 just to the right of it, and then just to the left, right here, this line right here would be negative 4. Then I'll move another full step over to this line. Well, that line would be negative 2, and this another full step over this way, that would be negative 5. Now again, the reason I want to use those points specifically is because they're going to match up with each other. Remember, you have that symmetric axis of symmetry, means these are symmetric. It means whatever answer you get for negative 3 will be the same for answer for negative 4. Whatever answer you get for negative 2 will be the same answer for negative 5. So that means really I just need to do two pieces of work. You'll do these two numbers right here. First one is going to be plugging in negative 3. So again, I'm going to come down here to my workspace, and I'm going to plug in negative 3. So this is for the t-chart. So I'm going to say y equals negative 3 squared plus 7 times negative 3 plus 12. And negative 3 squared is 9. 7 times negative 3, negative 21, plus 12. And that all turns out to be 0. So y equals 0. So when x is negative 3, y is 0, which would be the ordered pair negative 3, 0, which would show up right here. And then mirroring that onto the other side would be right there, which is negative 3, or I'm sorry, which is negative 4, 0. Again, I said to have a full parabola you need at least 5 points, so I do have to go ahead and do another ordered pair here. Negative 2, we're going to figure out what that is. So again, I'm going to go down to my workspace. Now, I've run out of workspace here, so I'm going to erase what I have here. You guys might have more, or you might be using scratch paper, which is perfectly fine too. So workspace here again, I have y equals negative 2 squared plus 7 times negative 2 plus 12. So I have 4 minus 14 plus 12, giving me y equals 2. So when x is negative 2, y is positive 2. That ordered pair over here on the graph is negative 2, positive 2 right there. Mirrored directly on the other side right there, which is your negative 5, positive 2. So there you have it. We filled out our t-chart, which was our step 4. You can now graph your parabola because you have your 5 points. Parabola looks like this. And now for step 5, where you tell me what the roots or what the zeros or what the solutions are to this problem. In other words, you tell me what does x equal in this problem. And again, they're called zeros because it's whatever x is when it's x comma 0. So like right here we have negative 3 comma 0, so x equals negative 3, and then x also equals this spot right here. So negative 3 and negative 5. Now, is there any other way to get those two answers, negative 3 and negative 5? Sure there are. There's lots of other ways to get those answers. I'm going to go back down here to this workspace just to explain this so you understand that you could have gotten that answer by factoring the original problem. The original problem was x squared plus 7x plus 12 equals 0. Two numbers that multiply to make 12 and add to make 7 would be 3 and 5, right? Or not 3 and 5. And that brings up a good point. Good thing I checked myself there. This isn't negative 3 and negative 5. This point right here is negative 4. Be careful. Don't make that counting mistake that I just made there. Negative 4. And again, you could see those over here in your t-chart too. What was x when y was 0? Negative 3 and negative 4. So sorry about that, and that then again brings up a good point that another way to solve this is by factoring, and the factors of 12 that make 7 are 3 and 4. So this trinomial would factor into x plus 3 times x plus 4 equals 0, and then when you set them both equal to 0, x plus 3 equals 0, x plus 4 equals 0, subtract 3 on both sides, x equals negative 3, subtract 4 on both sides, x equals negative 4. You get those two solutions by factoring. How else could you get those two solutions? Well, you could use the quadratic formula up here. Using your a, b, and c, plug those numbers into the quadratic formula. Your answers are going to be negative 3 and negative 4. Or, worst case scenario is completing the square. We don't like completing the square because it's the hardest method, but completing the square would also give you the two answers, -3 and -4. All right, so really the next four problems are all about some tricks, some special things that happen. We're going to go ahead and do number 2 right now, and then I think this video is going to be long enough, so example number 3 and 4 will be done in class together as some of our in-class examples. So let's go ahead and do number 2. Try to speed up this process a little bit since we hopefully know what we're doing now. Number 2, let's see. First of all, my A is 1, B is -4, and C is +4. So for my axis of symmetry, my step 1, x equals -b, which would be +4, because b is -4. -4 is +4, over 2 times 1. So x equals 4/2, or x equals 2 for my axis of symmetry. I'm going to go ahead and hold off on the graph in case I need to move it so I have a better idea of where this is going to be. And really all I have to do is hold off one more step. I'm going to hold off until I get my vertex, which my vertex is going to go right here. And I know my vertex is already 2 comma something. So down here in my workspace, I'm going to take y equals x squared minus 4x plus 4, and I'm going to plug in 2 in for the x's. So 2 squared minus 4 times 2 plus 4, 4 minus 8 plus 4, well, that's 0. So my vertex is 2, 0. Okay, so that gives me a good idea of where this parabola is. So it does look like I can go ahead and draw my xy axis kind of down the middle, because my dotted line is going to be at 2. There's 2. And my vertex is 2 comma 0, which is right there. So this parabola is right on the x-axis. Again, is this probably going to open up, or is it going to open down? And again, that's all dependent upon what your a value is. Again, in this case, my a is +1, so that means this parabola will open up. I don't know how wide or how skinny yet, but it does mean that as far as my max and min goes, this vertex is going to be the lowest point, so the minimum. Again, then my t-chart, I'm going to put my vertex right in the middle, 2, 0. That was my vertex. A number just bigger than 2 would be 3. A number just smaller than 2 would be 1. 2 bigger than 2 is 4. 2 smaller than 2 is 0. Again, I picked that because these two will mirror and these two will mirror. This work should be pretty easy because I can plug in the numbers 1 and 0, which will make things a little bit easier. Plugging in 1 into the equation will give me y equals 1 squared minus 4 times 1 plus 4. So y equals 1 minus 4 plus 4. Y equals 1. So when x is 1, y is 1, which also means when x is 3, because of the symmetry, y is also going to be 1. So I can graph those 2 points on my graph now. Still need 2 more. I can see that the parabola is opening up, obviously. 0, again, is always an easy number to plug in because, again, look at this. You plug 0 in here, you get 0. You plug it into that x, you get 0, and you got plus 4. So really, whenever you're plugging in 0, you're going to end up with whatever that last, c value was. So again, I'll go ahead and show the work down below, but it's not really that necessary. You have 0 squared minus 4 times 0 plus 4. 0 minus 0 plus 4. is 4. So y is 4 when x is 0, and again, because of the symmetry, y will be 4 when x is 4 also. I can graph those 2 points. So 0, 4 is right here, and then 4, 4 is right there. I now connect my parabola, and I now look for my zeros, look for my roots, look for my solutions. This is a case where the solution, or the solutions to this problem, there is only one solution because the parabola only crosses the x-axis in one point, and that one point right there is 2. So x equals 2. What you might remember from earlier sections is since you only got one answer, that means that the discriminant, if you would have plugged these a, b's, and c's into the quadratic formula, the discriminant would have ended up being 0. The discriminant would have ended up being 0, meaning that you're only going to get one solution, and that's because the parabola is actually sitting right here on the x-axis. Okay? So again, you could have gotten the answer of 2 by possibly factoring this or by using the quadratic formula, but you still got to know all these other steps because you still got to be able to graph the parabola. Alright, so that's enough for this video. We'll go ahead and do the last 2 examples in class. You should go ahead and try the last 2 examples on your own now. And again, there are slight tricks to the last 2 problems. You'll run into something slightly different than what you did in these 2. Alright, try them on your own now.